Hello folks, this is Jennifer. Today we will talk about LeetCode 785's graph bipartite. To clarify this concept of bipartite graphs, let's go through some examples. This may help demonstrate what makes a graph bipartite and how to identify one. Take this example provided in the question statement. There is an undirected graph with 4 nodes, where each node is numbered from 0 to 3. To indicate the 2D array input better, let's present it in this way. For graph 0, the subarray 1, 3 indicates that node 0 has undirected edges connecting it to both node 1 and node 3. For graph 1, the subarray 0, 2 indicates that node 1 has an undirected edge connecting it to both node 0 and node 2. For graph 2, the subarray 1, 3 indicates that node 2 has an undirected edge connecting it to both node 1 and node 3. For graph 3, the subarray 0, 2 indicates that node 3 has an undirected edge connecting it to both node 0 and node 2. And we can say this is a graph bipartite. Why? Okay, let's consider this edge. Its 2 nodes 0 and 1 are in different sets. For this edge, its 2 nodes 1 and 2 are in different sets. For this edge, its 2 nodes 2 and 3 are in different sets. For this edge, its 2 nodes 0 and 3 are in different sets. This allows us to identify it as a graph bipartite, as we can partition the nodes into 2 different sets. To further explain, we have a key characteristic of bipartite graphs. A bipartite graph can be colored using 2 colors, let's say red and green, such that no 2 adjacent vertices share the same color. So, based on this rule, let's do a quick test. Is this graph bipartite? If we color node 0 red, then according to the rule that adjacent node cannot be in the same color, nodes 1, 2, and 3, which are adjacent nodes to node 0, must be colored green. Looking at node 1, we see this node 1's neighbor, node 2, is the same color. So this breaks the rule for graph bipartite. We can conclude this graph isn't bipartite. Let's do another quick test. Is this graph bipartite? Feel free to pause here, take a moment to think about it before we continue. Answer is true. This graph is a bipartite graph. Did you get it right? Let's color this graph's nodes, starting at node 0. Adjacent nodes must have different colors, so nodes 1 and 5 get green. Node 5's neighbor, node 0, is already colored. Node 2 and node 4 get red. Node 2's neighbors, node 1 and node 5, are already colored, so node 3 gets green. All nodes are colored without breaking the rule. No adjacent vertices share the same color. This confirms that this graph is indeed a bipartite graph. Let's do another quick test. Is this graph bipartite? Feel free to pause here, take a moment to think about it before we continue. Answer is false. This graph is not bipartite graph. Did you get it right? Applying our coloring method to this graph reveals adjacent vertices 1 and 3 have the same color, breaking the bipartite graph rule. Therefore, we can conclude this graph is not bipartite. Alright, let's jump into the code. We will take this example as an input. I use an array named visited to record whether a node has been colored. As we know, for integer arrays, initial values are all 0. We can use any labels to distinguish between the 2 color sets. For this example, I'll use the number 24 to label color red and 80 to label color green. We will use a for loop to iterate through each node in this graph, beginning with node 0. Remember, our goal is to color each node and verify that no 2 adjacent vertices share the same color. This allows us to determine whether this graph is bipartite. We will only move forward with the next steps if this node we're looking at hasn't been colored yet. we prepare a queue in advance. Why? Because for the current node, we want to traverse its adjacent nodes. To do this efficiently, we use a breadth-first search algorithm. To implement BFS, we use a queue data structure. Add current node 0 into queue. Color node 0 as neighbor number 24, which is red. Standardize the BFS operation. We first pop the current value out. Obtain the color information for the current node with color number 24. At this point, if the current node's color number is 24, then adjacent node's color number would be 80. Traverse the current subarray 1, 3, which represent all adjacent nodes of current node 0. If node 1 hasn't been colored yet, we will color node 1 as neighbor number 80, which is green. Add such node into queue. For loop to continue to traverse current node 0's adjacent nodes. At this time, it is node 3. If node 3 hasn't been colored yet, we will color node 3 as neighbor number 80, which is green. Add such node into queue. As you can imagine, we will repeat these steps until the queue is empty. Then we return true, saying that this is a graph bipartite. In a graph bipartite, no two adjacent nodes share the same color. If this rule is broken, we immediately return false. I'll use another input graph as an example here. As you can see, when the current node is 0, we color it red, which is number 24. We then color its adjacent nodes 1, 2, 3 green, which is number 80. When we reach node 1, we discover its adjacent node 2 has the same color. This breaks the bipartite graph rule. We immediately return false, concluding that this is not a bipartite graph. Alright, I hope you enjoyed this video. If you did, please like and subscribe. Thanks for watching. I'll see you next time.